The Sphinx is best known from Greek mythology as an enigmatic guardian. But did you know that the Egyptian Sphinx statues were actually constructed as royal portraits? The Great Sphinx at Giza is thought to be a portrait of the pharaoh Khafra, who reigned in Egypt around 2500 BC. Regardless, the Sphinx has entered our cultural lexicon as an enigmatic riddler, most famously because of the riddle that guarded the gates of Thebes. What is the creature that walks on 4 legs in the morning, 2 legs at noon, and 3 in the evening? 4,000 years after its construction, Khafra's Sphinx at Giza would play an important role in a very different sort of riddle, unveiling the secrets of the atom.
Today, we take atoms for granted. Everything, all solids, all gases, all liquids, is made of tiny atoms too small to see. This was not always accepted. As late as 1900, many scientists disregarded atomic theory in favor of thermodynamics. Thermodynamics could explain why twigs break, why water flows, and even how steam engines could do work for us and make our lives easier. Would atoms, these tiny, unseeable particles, really make a difference? It was Brownian motion that would turn everything around.
What is Brownian motion? The story goes back to Britain in 1827 to a botanist, Robert Brown. Brown studied how plants reproduce. In his test with the pink fairy flower, Brown noticed something strange under the microscope. When immersed in water, little bits of pollen jittered around uncontrollably. Brown thought these jitters might account for the role of pollen in plant reproduction, so he expanded his tests to other plants. Pollen from plants of the same family as the pink fairy had the same motions, so Brown tested pollen from plants in a different family with similar pollen. Then he tested families of plants with different kinds of pollen. Then he tested families of plants like mosses that reproduce by spores. And finally, Brown tested plant matter from plants that reproduce asexually. When he observed the jittering motion in every single one of these cases, Brown gave up his hypothesis that the jitters were related to reproduction. He had found something unexpected.
Just how far did this phenomenon extend? Would the mysterious motion still be present when the plant was no longer alive? If so, how long would it last? Brown quickly discovered that the motion lasted long past the death of the plant. He found the motion in apparently dead products of plant life. He even found it in petrified plants and fossils. At this point, Brown began to suspect that this motion could be found even in things that were never living to begin with. He observed the scraped off dust of window glass and various mineral and earth metal combinations in water. He saw the same motion. In the end, Brown devised the ultimate test for the universality of the jittery motion. He needed something so old and so far removed from all organic material that it would be almost impossible for any living matter to exist on it. Where in London could he find such a thing? The British Museum held many relics. They included pieces from the oldest known monumental statue in the world, a monument that had outlived empires and eons, a relic more than 4,000 years old. It was from that enigmatic riddler, the Sphinx. Brown immersed tiny fragments of the Sphinx's statue in water. Sure enough, they jittered around, just like the plant pollen had.
Brown had observed the motion in just about every single type of material he could think to test. He concluded that this motion was universal. However, he had no good explanation for it. And for 77 years, no one could prove exactly what caused the so-called Brownian motion. It took until 1905 for Albert Einstein to finally put the debate to rest. In his year of miracles, Einstein showed that pollen-sized specks in water jiggle about, just as Brown observed, as a result of collisions with water molecules. It was the first thermal effect that ordinary thermodynamics could not cover. The skeptics had to accept that atoms existed. And that's how the Botanist and the Sphinx helped solve the atomic riddle and helped us better understand the world today.